Wait, I have this symposium is turning out to be really great. I think the combination of the people and the subjects is really, really interesting. It's really serendipitous, I think. So our last speaker is Forrest Meggers. Came all the way from Princeton this morning and is going back tomorrow, I think, or tonight. You leave tonight?
Tomorrow.
Okay, and he's an architect, and he has some really interesting. We were talking earlier about his ideas about simple things like temperature of a room. And he pointed out that the room really doesn't have a temperature. It's the air in it that is what we are mostly focused on. But that's not really what makes the room or a place feel comfortable. It's how we are.
You make us feel comfortable.
Okay, there you go.
Thanks. All right. Is everybody still with me? So you guys, you're going to have to teach me one thing first, and that's what the word yes is in Thai, so that when I ask you a question, I know what you're saying. And since it's the end, I'll make it easy. All the questions are usually yes. So let me hear a yes. All right. So as you heard, my name's Forrest. I grew up on a farm in the middle of the U.S., and I didn't have a green thumb, so then I became a bike mechanic. And now as a hobby, I'm a professor who plays around with temperature, as you heard. So I run the Chaos Lab. I am the self-appointed director of such chaos, and we do a lot of research on thermal systems, and looking into ways that we can reinvent the built environment. So one question I'll start off by asking you is, more broadly around the built environment and our climate in general, are we all in agreement that do we feel that climate change is a threat? Yes. Good, because I was talking about the fact that it's cold in here. So we change the climate a lot, and we change it by a lot more than the global climate change has changed. Every day you walk into a building, right? Every building in Bangkok with air conditioning is experiencing a lot of climate change. And it's no irony that that changing of the temperature in a building is one of the largest contributor to climate change globally. Because we use a lot of energy trying to make our offices feel good, when really we just want to feel like we're sitting here. And today, if we make it to the end in 18 minutes, I will teach you how we can make the tropics feel like they're being air-conditioned without changing the air temperature. So we have a lot to get through, but I just wanted to show this portion here. Buildings are uniquely positioned in our global changing climate in that they not only emit carbon and cause climate change, but they must then also directly respond to it and be resilient to it. If the temperature outside goes up in Bangkok, you have to use air conditioning more to stay cool. And what I want to talk about today is ways that we can get around these sort of fundamental linkages and kind of break down that connection and rethink how the built environment works. Because in Thailand, this trend is continuing up, and the biggest part of it is commercial and residential buildings in terms of energy consumption. And the biggest part of that is air conditioning. And all over the world for buildings are a huge part of our energy consumption, and the largest part is heating and cooling. That's why KAOS stands for cooling and heating of architecturally optimized systems. And unfortunately, we're not doing it very intelligently, so that is not a very efficient way to install air conditioners on a building, you might not be surprised to know. But we need to put them somewhere because we keep putting more and more and more of them in places. In the US, where I'm from, and Japan, we have well over 90% of households having air conditioners, but the rest of the world is going to very soon also have lots of air conditioning, and these parts of the world are a lot hotter. I took this picture 3 hours ago on my way over here. So you also don't necessarily install your air conditioners in the most efficient manner. And you are part of this global trend that shows in the forecast, right? This is the growing air conditioning units up until now, and the forecast is right now all of the big countries like the US, we do a lot of heating in the winter right now. There's a reason I have a jacket that I flew here with, right? I'm going to go back home and get cold again, and we use a lot of heating, but cooling by mid-century is going to dramatically outweigh the energy it takes for heating. And it's the global south and the tropics are going to play a huge part in that. So you may think now I'm going to tell you all the engineering solutions to that, and there's a lot of engineers that will claim, oh, there's a huge opportunity to come to Thailand, to come to Indonesia, and teach people how to make air conditioners more efficient. And I'm here to tell you that's not necessarily the answer. We can always make systems more efficient, but design and creativity is really how we're going to change the built environment. So I'll give you a couple examples of projects I've worked on very briefly. Back to this building in Singapore. I was in Singapore for 2 years doing research on cooling systems. So this is actually a very fancy building in Singapore. This was a Green Mark Platinum building, and they did a very intelligent thing, because we know architects and engineers, they love each other, right? They always get along? No. So the architect doesn't really like the way engineering systems look. So he does a really good job of, taking the air conditioners and hiding them behind that screen so we don't have to see those ugly things. But what does that mean for how they work? Well, we all know that hot air rises, right? And we know those machines are trying as hard as they can to push the heat out of the building, but they have to fight against each other. So we deployed a bunch of these distributed temperature sensors to allow us to measure that temperature, to see how much hotter it is at the top, because the hotter the air is around an air conditioner, the harder it has to work, the less efficient it is, right? But it turns out when we did these measurements that the hiding of the air conditioners that are here at the bottom, behind the screen with the louvers, forced all the air over to the side of the opening, and this caused twice as much warming as the vertical effect that we were expecting to measure the air getting warmer as it went up, but it turns out the architectural decision to hide the air conditioners decreased the efficiency of those units by 32%. And the funny part is that the 32% less efficient, that building, they bought the most expensive, most efficient air conditioners that you could buy in Singapore. And when you put them on that side of the building, they operated with an efficiency lower than the worst air conditioner you could have bought in Singapore. So engineers aren't necessarily going to solve all the problems when all we have to do is make the right design decisions. But unfortunately, even if we want to make those right design decisions, I have to go to a meeting and tell the architect that I'm going to save a bunch of money if you don't put those louvers on. I'm going to save a bunch of energy money. But for every dollar in energy I spend in a building, there's $10 of rent being sold, right? So I have a hard time convincing developers to make changes based on my energy claims. So another project we did in Singapore was taking this big, bulky area of ducts and re-envisioning that into a system that fits into the concrete slab of the building, basically taking these big plenum spaces that are the architect's default and designing them to be water-based systems that don't take as much space and allow us to basically have 3 floors with the same ceiling height. So standing inside them, they feel the same, and they take up exactly the same amount of height as 2 floors in the case of that building that we were working in Singapore. So we actually got the chance to get some funding from Siemens to do a demonstration in Singapore, and so we built this office space. Turns out, when you figure out a way to fit more stuff into the building, people don't always want more floors. In this case, they just wanted more floor height, which maybe you might appreciate as an architect. So we were able to install all of the systems in the building integrated into this small section of the facade, and we're able to save a huge amount of space and energy in that building, and then we applied this wasn't across the whole tower, but we did a paper in Tall Buildings Journal just discussing how there are so many synergies that come about when you start thinking about the spatial implications, how much volume it takes to install systems in buildings. And then we proposed this across a few different renovations that were going on in Singapore, where you can tear out these large plenum spaces and activate the thermal mass, use the concrete material that's already there as a cooling material, and then integrating solar panels into these facades that leaned out so we can basically take the air directly from the facade. The reason we have such large ducts in buildings is largely there's one place the air comes in and we have to blow it through the whole building in giant ducts. But if we use a distributed system, we can use small ducts and small systems that are right at the facade, saving, again, lots of space, which, as I pointed out, is much more valuable than the energy I'm saving, even though, at my core, I enjoy saving all of the energy in the building. So those are two ways that we can rethink the way we design systematically as a team, as engineers and architects working together. But the next part is we're going to go into all of our own deficiencies in understanding the thermal environment. And first I have to ask you, is Thailand hot? Yes, Thailand is hot. Unfortunately, Thailand is not hot. People in Thailand get hot. People are hot. Thailand is not hot. Thailand is not hot, and we alluded to it earlier. People are the things that get hot, right? You sit there in the sun, you warm up, you have to adapt. And there's one more variable now that's even more important than rent. For every $1 in energy and $10 in rent, in a building you're spending $100 on the salary of the people working in a typical office building. So that's the reason we like to make sure our office buildings are air conditioned, because I want everybody in there working as efficiently as possible, right? If I'm Chase Bank, I need all my employees at maximum efficiency. And the way we think we do that is scientifically air conditioning everything. We've actually only had air conditioning around for about a century. Yet in 50 years, we've spread it almost everywhere in the US, and it's obviously available all over the world here. But there's a lot of intuition that was developed just before the ubiquitous spread of air conditioning across our built environment. And that was around how the human body adapts to heat and climate. So bioclimatic design is something that I actually stumbled across when I first got to Princeton, was being researched and understood that not just air temperatures, but also radiation. So if everybody's seen Predator, Arnold Schwarzenegger, I don't know, it's a little throwback. But there's a lot of thermal images in there. So I carried up my little thermal camera here. I'll turn on. So you have these little thermal cameras, which is what the Predator used to hunt down all of our friends. And they see radiation. And in fact, all of you right now, the idea of whether I asked you if Thailand was hot or if this room is hot, half of what your answer is coming from is radiation. Only half of it has something to do with the air temperature. A full half has absolutely nothing to do with air temperature, which is the thing the thermostat in the room is reading and telling the building how to be comfortable. So half of it is air, which are all these things we're very familiar with. Temperature of the air, whether you have a fan blowing on you, if there's humidity in the air. But half of it has only to do with the surface temperatures around you. All the surfaces in the room, the people sitting next to you, their surfaces, and those material properties of the surfaces surrounding you. So this brings us to a lot of different ways to think about making buildings comfortable, right? There's a lot of debate about active or passive systems, but really what I want to come back to is the building is not the thing that we want to make comfortable, right? The room is not the thing we're making comfortable. It's you. And I can do that using these other means, right? I can use it by understanding that I am orange, right? I hope I'm orange. Usually I'm orange with this thing, right? I'm warmer than the surroundings. If I took this outside in Bangkok, I would still be warmer than the surroundings, right? Our bodies are warm. And all that's really happening in terms of comfort and what a building is trying to deliver to you is the most effective means for your body to get rid of the heat it needs to get rid of for you to exist, right, comfortably. And we can do that also with radiation. So now I'm going to try and run through, I might have to jump over a few for time, some of the projects that we've done to exploit, take advantage of this radiant heat transfer, the radiation that you emit, right? And not to hunt you down like the Predator, but to make you comfortable. So one of these was using reflection. So we already saw this, right? How you can cook things by reflecting sunlight onto a position. Well, it turns out all of that infrared radiation that I just showed you with the camera and Arnold Schwarzenegger, right? That reflects the same way. So we can play around with the geometry of how radiation bounces off surfaces and steer it. So we invented a pavilion that focused the cold, small surfaces that we created on specific points in space and allowed us to then cool down people simply using evaporation and a small number of pipes. So the nice thing about being in architecture today is that we have a lot of access to digital fabrication. So we were able to make the reflective forms, right? Because now we're talking about surfaces. And if I want to be really specific about how a surface reflects light onto you, even though it's light you can't see, I still need a very specific geometry. So part of the research here was to see what we could build geometrically. And so we made these cone shapes. So there's all these cones that will come into being. And inside each one of these slots, there'll be a pipe. And the pipe is the only thing that gets cold in this project. These little black pipes that we're putting in there. Nothing else gets cold about the surfaces. Because you know it would be kind of dumb? Making a huge surface cold outside, right, when it's hot out. So I want a really small surface so that I don't cool down the air, because the air doesn't stick around in one place when I'm outside. So this thing, right, which was called the thermoheliodome, used evaporation to cool down those pipes. And then you can see here, the whole cone, because of reflection, appears to be cold, even though it's only the small pipe in the middle that is actually cold. And so we did several experiments here. You can see again the thermal camera. The only piece that's cold is that in the middle, but the whole thing looks cold, right, and makes you feel cold. And so this operates with 40 times the efficiency of a typical air conditioner, and at the same time, it makes people feel comfortable. So we did a full comfort survey, even though this farmer from Iowa, who happens to be my dad, was a little biased. We did have some other human subjects that came through the dome. And then we tried another version of this at the Seoul Biennale, which I will go through very quickly. And in this case, what we did was we again used geometry of surfaces, in this case, parabolic surfaces, to steer a bunch of cold pipes. These are all cold ones. So they all point down this hallway this way, and all the hot ones point the other way. So the hallway is all one temperature. There's a big thermometer. It all is the same temperature, but one side feels hot and one side feels cold, completely independent of the temperature. So a big part of this is playing again around with geometry and how rays get traced and bouncing heat around through radiation. And then we installed thermal cameras, again, that allowed people to experience how that changed as you walked into this dark hallway. And we also got to have some fun creating the hot and the cold side of this system in balance with each other. And one of my PhD students that works with me now is building these new ray tracing models, basically taking techniques from computer graphics and gaming and using that in the infrared to understand how we can steer heat spatially, right? I can make this part of the stage hot and this part of the stage cold, and there doesn't need to be a wall here, there doesn't need to be two different rooms, to rethink the way we believe we need to heat and cool the environment. So the last project, more relevant to more relevant to Thailand probably, is this pavilion that we built last year in Singapore. And what we really wanted to do was radiant cooling of the outside in Singapore. Does anybody know what happens when I try and make really cold surfaces outside on a really hot, humid day? Does it get condensation on it? Yes. It gets wet. So things that you take outside that are cold in the humidity, in the hot, humid climate, in the tropics, that makes it really hard to do cold surfaces, right? So we came up with a trick. And the trick was, I called it thermal magic. There's actually a thermal camera behind this white piece of plastic here. It just turns out that that plastic is totally transparent to the long wave radiation, to the light that is infrared light, right? So the heat can go through that membrane, but you know what can't go through that membrane? Humidity. So the moisture gets stuck on one side. And so the trick is, you can see my hand thermally through in this picture, but you don't see it there, right? And so this allows, these are just graphs of all the heat. So we use some microscope techniques to look at the infrared transmission through this material, and we invented a panel that was dry on the inside and has a membrane that keeps it dry and then allows us to make really cold surfaces outside in the humidity, in the hot and humid tropics. And so what that does is now, remember, all your body is doing to stay comfortable is shedding heat. So now when I put you in this pavilion in Singapore, right? So we build a pavilion and we put these membranes in front of them. This one is white. On the inside, we left them clear so we could observe what was going on inside. So there's clear to both radiation types. And then people become a little bit euphoric because it's 30 degrees, but it feels like 24 degrees all of a sudden. But the air with the thermometer is still 30 degrees. You just feel like you've stepped inside, even though you're still outside, which is kind of a magical thing. And it was a little bit exciting for a lot of people in Singapore. And so now we're thinking about different ways we might implement it. So here you can see us playing around with the thermal camera. You can see how cold the surfaces are behind us. But we're talking with schools, particularly in Singapore, naturally ventilated schools. This would be a way that we could significantly augment cooling and enable natural ventilation to go on. Open-air markets and bus stops, these are all places where we could do cooling. And again, by having the membrane, I'm not allowing that thing to cool down the air, because cooling the air outside is kind of wasteful, even though I've seen restaurants blowing cold air on people in various situations. So last but not least, then, I'll try and go very quickly. How do we measure any of this? So the last problem that we faced was, how do we prove that any of this works? So we've built a lot of sensors, right? One of them is that with radiant systems, we should focus on air being for breathing, not for heating and cooling. All of those systems use water, right? So we've done a lot of papers on developing air quality sensors. So air quality is a super important component, measuring exactly what's in the air. I built badges that people wear and march around with and collect data for me. But this is the only way I have to measure radiation, that part that we were just talking about. It's a really dumb thing. It's just a sphere painted black. So we've been inventing new ways to measure that variation of the thermal radiation in an environment, right? So we want to know exactly how all the different temperatures around you average out to become a new mean radiant temperature around you. And so we've built several different versions of this. We did one spin-off company called Hearth Labs that's working on making a device that scans these temperatures. So you can see the 3D point cloud that's made, and we can calculate that here the temperature in the room feels 1 degree warmer than over here, even though, again, air temperature, totally the same. And we can get strategic about how to design that, right? We can also look at very complicated buildings. This is a large library in Princeton, and so you can see how we can look at where people are in that space, look at the distribution, and calculate exactly how the heat transfers to them at different points. And most importantly then, now if you imagine that person's in there and I'm doing a scan, the other thing that we see is people. So to conclude, I would like to claim and hope that in the not-so-distant future, we can actually stop trying to make rooms comfortable and start actually making people comfortable. Because if I know your hand temperature and your face temperature, right here, some of you probably have kind of cold hands, right? Your hands change temperature by a lot. And I can teach a building to respond to how your body is changing thermally, right? I don't need to use some stupid set point on a thermostat, right? The only thing a thermostat's good at is making sure 20% of people are always uncomfortable. That's one thing you can remember. And so we're hoping to move forward with this kind of research in the future to make it so that you can have the sensation of being here, anywhere, and also with the same energy demand that that building takes. So, thank you very much for your time.
ต้องขอบพระคุณด้วยนะคะท่านวิทยากรทั้ง6ท่านด้วยกันนะคะจากหลากหลายประเทศเลยจากทั่วโลกเลยนะคะวันนี้ได้รับเกียรติจากวิทยากรระดับโลกนะคะจากหลากหลายองค์กรนะคะหลากหลายหน่วยงานมาร่วมกันนะคะเพื่อที่จะระดมสมองนะคะแล้วก็นำ case study ต่างๆมาให้ทุกท่านได้รู้จักกันค่ะสิ่งที่เห็นได้ชัดเลยนะคะของทุกท่านที่มีตรงกันแล้วก็คล้ายกันก็คือการ generating good โดยใช้ดีไซน์นะคะมาทำให้โลกของเรามาทำให้ตัวเราเนี่ยมีความสุขมากยิ่งขึ้นค่ะตัวอย่างก็จะเห็นได้ชัดเลยนะคะไม่ว่าจะเป็นเมืองญี่ปุ่นนะคะที่มีดีไซน์วีคเองก็ตามนะคะเพื่อที่จะช่วยสนับสนุนให้ชาวประมงที่ไม่สามารถที่จะจับปลาได้นะคะมีความรู้สึกนะคะและสามารถอยู่ได้อย่าง sustainable ค่ะนอกเหนือจากนี้ก็เป็นการปรับปรุงเปลี่ยนแปลงภูเขาขยะแล้วก็ทำให้เกิด land lab ขึ้นมาได้และสิ่งที่น่าสนใจมากๆเลยนะคะคือการ สร้างพลังงานนะคะที่เกิดจากสิ่งรอบตัวเราเลยทีเดียวค่ะเอาละค่ะลำดับถัดไปนะคะที่ฉันขอเรียนเชิญสปีกเกอร์ทั้ง6คน May I please invite all the speakers on stage to proceed with the next item on the agenda which is the Q&A question which our audience has already submitted through the QR code เรียนเชิญทุกท่านบนเวทีเลยนะคะซึ่งก่อนหน้านี้นะคะซัมมี่ก็ได้ให้ทุกท่านนะคะถ่ายภาพ QR code ไว้เรียบร้อยแล้วนะคะสำหรับท่านไหนที่ส่งคำถามมานะคะรอดูนะคะว่าคำถามของท่านจะได้รับการคัดเลือกนะคะจากทีมงานของเราหรือเปล่าในการถามนะคะ
I thought we would start off before we ask their questions. If the speakers had any questions for each other or comments on their speeches. No?
Maybe we can come back later. Yeah?
Guess so.
Okay. If we have some more time. Yeah. เอาละค่ะเดี๋ยวมาเริ่มเป็นคำถามแรกเลยค่ะขอคำถามบนเวทีเลยนะคะคำถามแรกค่ะ It seems like all of you guys have one thing in common is to encourage people to make change. Question is, how hard is it to bring this many people together?
Well, I don't care how hard it is, but we're going to have to do it.
Okay. Anyone else would like to contribute to this question?
On all the projects I showed, and in my team, I always have at least 3 different kinds of engineers plus architects working together, but they're always young, never the old ones.
Right.
No, I'm just kidding. Not never the old ones. But I would say that the younger generation that are still in school right now, there is more incentive and more infrastructural support, like what was shown at Hong Kong, for people to be working outside of the sort of conventional disciplinary boundaries, and that enables the change that I think they're asking about. And certainly there are people working out in practice that do as well, but often we get siloed the older we get. I do just as much as anybody else, and I think that's something to work against and try hard to.
I think that perhaps the question would like to address the difficulties that getting people to work together and how can you overcome that in order to arrive to the success.
Yeah, there's a lot of disciplinary knowledge, and so I feel that when you're working in the world of architecture, you're thinking about the world of buildings in a certain light, but if you're working with people who are engineers for that same building, there's a conflict between where and how engineers talk to one another and how architects talk to one another, but they don't often cross over that divide. And so I think more opportunities for crossing that divide is quite critical, and to bring people together. Even when you work on a building, you work on your part of the building, and then the engineer is working on that zone. It even says in the drawings, like, don't touch that 2 meters. That's for someone else to worry about. And so part of what we're also doing is making sure that that conversation also continues to happen across the divide of the disciplines. And I think that's a big challenge, I have to say.
Listen, guys, there's more than architects and engineers. There's artists and designers and stuff like that. So I think that we have to get everyone involved.
Yeah, and also the general public. I think a lot of the work that we're doing is also to make sure that the message that we are thinking about and having conversations with ourselves reach the whole population. And that's why we also focus on a much wider range of audience, from anyone who's super young to already retired, to make sure that that conversation also occurs not just among us, but throughout society.
Well, the Design Trust was doing a lot of that, is doing a lot, right?
Yeah, it's a really great question that is being explored. I think we're lucky because we're an NGO. There's a trust for nonprofit organizations. So, and maybe because we straddle between different stakeholders, there's a level of trust building and communication. That's why I think communication dialogue. But it's a really interesting phenomenon on being able to, through design, diplomatically communicate with multi-perspectives. I think that's maybe the design education or training, that you are allowed to fail and getting everyone on board to realize we're all taking this risk and a trial together that actually allows people to open up. So I really do believe this model of open generosity and dialogue and communication is key. However, it takes a lot of talking. Like I should count my log in how many hours of emails and meetings one actually needs to activate. And I'm sure the same thing with the fisheries and building the empathy and community spirit is the hugest achievement. And that's.
But I saw in one of your projects, specifically you had like people building models of what the park was going to be like, and the people all relating to the models is a lot, I find, is the best kind of communication, because it's not some abstract idea or some people think it has some relevance to some whether that's like a Republican idea instead of a Democratic idea. It's like, hey, that's a good idea.
The other thing I noticed among all the presentations is also the things that are being presented are all works in progress. They're not final ideas in a way. There's things that, and also what I love even before we joined together on stage is that we were downstairs and everyone had different things pulling out of their pockets. I think you have something.
Yes.
Yeah, like everyone has different devices that they're working on at the moment that is also proving different ideas. And I think that's also that sense of national curiosity that each of us can do something within what we do every day that can contribute to small parts to these larger problems is quite important.
I want to paint my fingernail green now.
Just one.
Andre?
Yeah, my team also have people between 4 and 12 years old, a bunch of different skills, and we always fail. Like a little group do one thing, but they fail to, like the solar power balloon. Each group develop a different part. One group develop how to close the balloon. The other group develop how to make it bigger, and each group fail, but in the end, each one add a little bit, and we could make the solar power balloon to fly. So I think, as you were saying, is like a collective project. It's not like I did this new material, but if we teach, like if you let it open, I think it would be easier to, in 10 years, make this change happen instead of being in the individual, be like more like a group.
Yeah, actually, it's really good from your presentation about working together collectively, and I believe that, as you mentioned, that regardless of the difficulties, we're just going to have to make it work, which coincides with the theme of the Bangkok Design Week, which is resilient. So actually, I have my personal question for all of you, if you'd like to add to this. I mean, as a designer and as the academia and the artist, you must have faced failure uncountable times. How do you bounce back? How do you use resilience as an inspiration, or perhaps is there any process, a thinking process that you'd like to share with the designers sitting here in this room?
Well, first of all, I don't really think about it as a failure. It's just like another challenge or an opening of a new idea, and if you think, it's not a failure.
So it's the mindset that matters.
Yeah.
Yeah, great. Great start. Anyone else like to add to that?
Well, yeah, it's always it's not that it's just not a failure. I think the most important thing to think about when you're wondering about someone's process, like I guess it's about process in design, is a failure. I would say it's a bit of a cliche to say you learn from the failures, because in reality it's the translation of the idea into something, right? And that's why there's no failure, because eventually the idea becomes something else, and you're supposed to say like, oh, that first part failed. But in reality, it's just your ability not to give up on something, really. which is the resiliency thing. But I think it's be careful if you start looking for the failures to learn from them, then you're going to end up thinking things are wrong, and I think that's creates more risk of not progressing or not being creative, right?
Okay. Do you
No,
want
just to add in teaching, there's always this, especially when you're teaching something that's design related, there's always this ambition for the person who's learning that there's a correct answer somewhere in there that they're looking for. So I think it's also acknowledging the fact that sometimes these questions don't have any particular correct answer, but you have to be able to understand your answer, your contribution, independently of all the other contributions that could have happened. And so I think there's always that conversation as well about, even with yourself, that you're not after, there is no perfect answer to anything.
Yeah, I think that's one of the biggest problems with students. Their biggest failure is when they think they have the answer, and they're done. I figured it out, I'm done. They're not.
Yeah, I mean, to answer this, the same question the same way, actually, I think reflecting as well, my biggest failure was when I thought I had achieved something at one point in my life, and I realized that was quite premature to think about it that way. Perhaps the failure is in the unseen.
Would you like to add?
Yeah, no, I think just reflecting on a lot of the presentations and projects about this challenge, and I don't know if it's inherent in the DNA of designers or design educators or architects or industrial designers, is this commitment to, I think a commitment to really achieve something that goes beyond your expectation. And I think that becomes part of that discipline where the designers are always constantly working, 24 hours, 7 days a week. And that adrenaline of discovery, I think that is what keeps that resiliency as part of character building. So you can see, for example, I imagine your commitment to see that balloon, it must fly. There's that kind of desire to achieve, or the Play Kits project that Eric and I worked on, we challenged ourselves to create a new interior environment every day with the same materials 14 times over, which is also a challenge to how the normal way of working could also be challenged. So I think it's not so much resilience, but it's that drive of constant renewal that allows us to propel us to move forward. And I don't know, I think that's something I'm always actually interested in analyzing. I don't know if it's psychology of design or the psychiatry of collaboration from a design education standpoint that allows us to be committed to keep changing or keep renewing. Yeah.
Okay. Thank you very much. Anyone like to add anything else? No? Yeah?
My experience for the design education, and also think about it more deeply about the design process, and we have to think about it more carefully, and they're comparing it with the observing and so inciting. Yes, and how to get the first awareness of the design. That's going to be very important things to educators for the next generation, for the who are interested in the building their own design process.
Lovely. I think we've got a really well-rounded and comprehensive answer to that question. Thank you very much for answering my question.
Yep.
So we've got one last question from the audience. Okay. So the question is, from trends of combining different disciplinary together, for example, art and science, would the knowledge needed in the future be completely different? It's a very easy question. Anyone would like to be the first one? Go ahead, Andre.
Temperature.
No.
I think the knowledge is already outside there. Like after doing this solar barbecue, I was talking to a friend and he said, oh, we do that in Scouts. Like when you go camping, you can get a little plastic and put water and make the fire start like that. So the other technologies are already around. You just have to make it more spread around.
Accessible.
Yeah, accessible, spread around. So nothing, I don't know if it's nothing new, but you just have to.
Yeah,
anyone
I think
likes-
in the
yeah?
I don't know.
I think in the future, there's going to be lots of new knowledge and things we can't imagine today. But what's really important is about how we are creative in using it and being like empathetic to the environment and other people.
Okay.
Yep. If you give me enough material science, then buildings won't need walls anymore.
Okay. Anyone else would like to add to that in the future?
I'm just being provocative.
I mean, we are living in, we were actually in a symposium 2 weeks ago. It's no longer climate change issues, it's climate emergency. I think there are a lot of critical issues that we can't take for granted. And I mean, your presentation struck to me because it's extremely critical in terms of cooling and radiant heat. And this kind of knowledge, it's common sense in one sense, right? And how do we create common sense knowledge as part of our future learning? It's really going back to the basics. And I think that's where we, in the future knowledge, it should really be back to utilitarian needs, waste streams. I mean, we're also been talking to another group of people who've been analyzing food waste streams. So how can you create RFID or new technology that actually starts to sense the amount of food that we're consuming? What's happening in Hong Kong and China is a threat. It's not hilarious anymore. It's reality of health and sanitation. It's pure common sense knowledge. So I don't know. I feel like future knowledge is really re-examine the basics. And that's kind of my provocation.
Okay, I was told that we've got a couple more questions being begged to be asked to all of you because they're so interested. So let's have another question. ขอคำถามต่อไปเลยนะคะ So
That one's hard to read.
this is in Thai, and I'll just translate it, okay? The question is, in the aspect, so the question goes to the design trust. Where is the fund of design trust being accumulated from, and how to raise the fund that becomes the most effective?
Yeah, so my role, besides distributing and sitting in all these committees and awarding grants, is a huge event we run annually, like a fundraising gala. So we build patrons of the arts and designers, philanthropists. We have a really incredible board of directors who come together to build a benefit committee to fundraise. It's a glamorous event. In New York, it would be maybe the equivalent of Asia's Met Gala, perhaps. So that's one source of funding. We work very closely with building corporate trustees. And a very important partner now is with the Future Studio program is getting government grants. So we're very much public and private funded, but mostly out of the pure patronage of private individuals right now. Yeah. Great. I hope that answers this. But we hope we can build more capacity. Yeah.
Okay, มีคำถามหนึ่งใช่ไหมคะ ขอคำถามหนึ่งเลยนะคะ This will be the last question. Okay. So it seems investing new mindset among kids be the strategy, I suppose, for the future. Could you share the learning of the type of learning tools to attract them? Perhaps it's, I don't know, personally I thought maybe Andre's way of teaching is the way to go forward.
What I learned is that they will not do what you ask them to do. So I have this hammock. And I said, you're free to go to the hammock anytime you want. And they're chasing to go to the hammock. first, and they stay in the hammock. But then after 2 days, they cannot stand to be in the hammock anymore, and they come back and say, "Oh, can you please tell me what to do?" So what I learned was that you just have to. So they have to build a will to do themselves. If you say, "Hey, can you do it for me?" Probably they will not. But if you give them the option, "Oh, you can work or you can go to the hammock." You may think, "Oh, that's not a good option because they always go to the hammock."
Right.
But with the process, they learn that they also want to work. That just staying in the hammock is boring. So they come back to work with more energy and more will to do it.
Is it like the drive and the
That's the more important too, I think.
But I think the big problem is that the kids are really creative, interested, curious, all those things, and we gradually teach them how not to do that anymore. We want them to sit down, shut up, go to school, work, come home, It's like, I think that the problem is the older people, not the younger ones.
So what would be the ideal world of giving them the
Everyone's
creativity?
5 years old. No.
Do you have any thoughts I've got a 9-month-old son, and I know that I want him to grow up to be creative. So what is it that how do you incentivize them to be creative? You're all, the majority of you are designers, so were you raised or born that way, or how did you?
No, I think you just have to let them explore, let them make their own mistakes, and and encourage that.
Yeah. Well, I have 4 daughters, and my wife says she has 4 daughters and 1 son.
I can see that.
Yes. And they have monkey bars that go all the way across the house from one room to the other.
Right. And you join them as well?
That we built. Yeah.
Oh, right. Okay.
So if you stay a child inside, you're always going to be building things, and I'm leaning toward building as being something that's fulfilling, but one thing I was going to follow up was just to say, I think it's most important to realize that you can't fulfill a kid. A kid can only fulfill themselves, and you can only give them opportunities to do that. And they may not like building things, right? So I think that's kind of the hard part, is sometimes you just have to step back and be like, kids are going to grow up, and that's hard.
Yeah, in the other point of view, also you cannot, what you learn in teaching drawings to kids, is that you cannot judge the kid as being an adult. Because you can be a kid as an adult, but you cannot also do the other way around, to think the kid is an adult. Because a lot of teachers do that. "Oh, that's not good enough." But you're thinking as the kid is already older. If you respect the each steps, and the kid do that thinking, "Oh, that's very cool." Sometimes it's...
So I think wrapping up would be just to build an environment that is creative and thought-provoking, and let them explore and try and remain in the kindergarten for the rest of your life, basically, right? โอเคค่ะ และนี่ก็เป็นคำถามสุดท้ายนะคะสำหรับ panel discussion ที่ได้มาจากคำถามมาจาก Q&A นะคะขอเสียงปรบมือให้กับวิทยากรทั้ง 6 ท่านบนเวทีด้วยนะคะ